All right, good morning.
Morning.
Let's see, let's do an attendance ping to start. And let's start talking about ODP 414. So this caused a number of people some troubles. But this is a really good exercise for thinking more about strings in C and thinking more generally about algorithms, ways to describe procedures in a way that we can convert into a programming language. And it's kind of representative of the other ODPs that we'll be doing this week. So it's a good one to spend some time thinking about and talking about. So reminder of the setup here, we're trying to write a function named mix, and that takes two input strings and an output string. And the goal is to interleave those two input strings, so string 1, string 2, mix them together, so you get, you know, the first character of each, followed by the second character of each, followed by the third character of each, and so on, followed by a null terminator. That's what your output string should be. So you're constructing this kind of barehanded from these two inputs. And so there's different ways to do that. And we looked at one approach yesterday, which was something like, you know, for I equals 0, I less than string length of A, I plus plus, and this is pseudocode. But something like this, right? So go through each character of your input strings and copy them into the correct position in your output. And so if you look at your output string, and you look at the index of each of these positions, what we want to store in here is A bracket 0, B bracket 0, A bracket 1, B bracket 1, and so on. A bracket 2, B bracket 2. And so this index arithmetic comes kind of by inspection, right? Element 0 of A and B gets stored in elements 0 and 1 of your output. Element 1 of A and B gets stored in elements 2 and 3 of your output. Elements 2 of your inputs get stored in elements 4 and 5 of your output. And so it looks like A bracket I goes into output 2 times I, and B bracket I goes to your output 2 times I plus 1 more. And so you can make a loop like this. And at the end, if our strings only had 3 characters, right, this would be where we would write the null terminator, which is at position 6, which happens to be twice the length of our strings. So that's a general formula. So that'll certainly work. And I think that was the algorithm we developed yesterday. And it works great, but you need to figure out this index arithmetic, right? Which in this case was not too bad. The A's went into the even spots, the B's went into the odd spots next to the A's. So it's 2i plus 1. You scratch your head over it, and then the next time you have to do it, you'll get to that more quickly. We also have to deal with this null terminator, and this is potentially a little funny, but that's one way to do it. A different approach to doing this would be something like this. So instead of trying to calculate where in the output string our character should be copied to, I'm just going to have a variable that tells me the next position in the output that I want to save something in. And I initialize that to 0, and every time that I copy something from my input to my output, I store it at that location, and then I increment my output location. And this is perhaps closer to the spirit of, if we're trying to interleave the strings A, B, C, and X, Y, Z. This is closer to the spirit of, okay, take the first character from here, add that to your output. Take the first character here, add that to the next position in your output. Right? This to the next position in your output business, that's what this is doing. Outlook always shows me where I want to write the next character. So now I read the next character from B, from my first string, add that to the next position in the output. Read the second character here, add that to the next position. Read the third character, add that to the next position. Read the third character here, add that to the next position. And now when I'm done reading my input characters, I still have to write a null terminator. Where do I write it? In the next position. So if I keep track of where I am in this output string that I'm building, at the end of my loop, it's time to write the null terminator. I still just use my output location variable that tells me where the null terminator goes. And this kind of approach is going to lend itself really well to ODP 416, where we don't have a way to calculate where each character should go in the output string because it depends how many X's we're deleting. So this definitely works, right, for 414. This will do the same thing. And it would be, most ideal to understand both of those. But this version of code is what I think of as kind of, cobbling together a result, sort of building the output string piece by piece in exactly the way that you want. I have frozen again, I know. Let me try to reset that. Testing 1, 2, 3. Hey, there I am. So questions about this?
I think the only problem I had on it was not including the null terminator.
Mm-hmm. And that's often a big gotcha. And in the case of an empty string or a string with one character, sometimes that becomes sort of an extra special case that we need to deal with. And if we think it might be an extra special case, we can always throw in a check here in the beginning. I could say if the length of S1 is 0, then set out bracket 0 to the null terminator and return. And then I don't have to think too hard about it. But it's comforting sometimes if we have one algorithm that works for like all the special cases, all the edge cases. That kind of helps us feel like our algorithm is probably pretty solid. But sometimes there are special cases. Sometimes there's edges that you just have to deal with differently, and that's totally fine. And null terminators, a lot of the memory of a computer is filled up with zeros. I'm not sure why that is, because memory doesn't boot up with zeros, but lots of code uses zeros, and so if you just kind of look in memory, you're probably going to find a lot of zeros to begin with. And so if you forget to null terminate, or you null terminate in the wrong spot, there's a possibility your code will still work sometimes, right? It may, for example, if my output string happened to begin with all zeros, and I don't bother to put in the null terminator, this code is still going to work. Because, you know, I'll copy my input characters to the right place in the output, and what I don't copy into has a null. And so some systems will initialize a string to contain null terminators, and that might work, but that would only work, you know, the first time. And then if I tried to reuse the string, there might be non-nulls in there. So yeah, sometimes you get that behavior. Alright, you're good with the ping. So something that came up in office hours this morning, and this kind of surprised me. So let's say you're writing your code like this, and you're doing I equals 0, I less than string length a, and let's just rethink strings. So suppose your string is A, B, C. Your string length will return a 3 because you have 3 characters, and remember there's a null terminator in the 4th position here. So if we iterate by I equals 0, I less than string length, I plus plus, right? So what does this do? It sets I equal to 0. It checks to see if 0 is less than the string length of our string, which it is. It'll do some stuff. And then at the bottom of the loop, it will set I equal to 1. Goes back up to the top of the loop. And it checks, is 1 less than the string length? Well, string length is 3, so it is. So it'll go ahead and do stuff on character 1. Bottom of the loop, it increments I to 2. Goes back up to the top of the loop. 2 is less than the string length, so it's going to execute the body of the loop a 3rd time. It's going to increment I. Go back up to the top of the loop. Now it's going to say, is 3 less than the string length? Is 3 less than 3? Well, it's not. And so it's going to exit the loop. And so the body of the loop, this set of lines, gets executed a total of 3 times. The first time I is 0, the second time I is 1, the third time I is 2. And that's exactly the behavior we want, because when I is 0, we're looking at, you know, element 0 of our string. We're doing something in our loop with the A. When I is 1, we're looking at index element 1. We're doing something with the B. And the last time through I is 2, we're doing something with the element in index 2, which is the C. So we've done, you know, our processing in this loop body 3 times, once for each letter. So that works great. Here's the really weird thing that came up. So I usually think in terms of inequalities, but you could also try to do the equivalent by saying this: for I equals 0, I less than or equal to string length minus 1. Well, if the string length is 3, string length minus 1 is 2, this is basically saying loop while I is less than or equal to 2. And it looks exactly the same. When I is 0, it'll do the loop. When I is 1, it'll do the loop. When I gets up to 2, 2 is less than or equal to 2, it'll do the loop. And then when we increment I to 3, 3 is not less than or equal to 2, it'll exit the loop. So in most cases, this works exactly the same as this. But there's a notable exception, which is if your string is empty, this will not work. And this surprised me. And it's just something to be aware of with string length. Using string length minus 1 in a for loop will sometimes get you into trouble. And here's the reason. If you look at string length, it doesn't actually return an integer. It returns something called a size underscore t. It's a different type of variable. And a size underscore t is basically an unsigned integer. And the idea of an unsigned integer, so normally integers use 2's complement, right? Think about, engineering 250. We have this signed bit in the leftmost position, and they can go anywhere from some positive number to some negative number. So with 32 bits, an assigned integer can go between like plus and minus 2 billion. If you say, I don't care about negative numbers, let's always treat this number as positive, then you can go from 0 up to 4 billion. You get a bigger range. And so this thing returns an unsigned integer. Well, here's some test code. So I have an unsigned integer named I. I set it equal to I minus 1. That's like, string length minus 1. And now I'm going to say if I is less than 0, that's good. If I is bigger than 0, that's bad. And if I run this code, guess what? It says bad. So I starts off at 0, I subtract 1, and my result is positive. So 0 minus 1 is positive. And that's not something we expect. But that's exactly what happens here. So use caution doing arithmetic on string length. It's okay to compare it to something, but if you start doing arithmetic, you've got to keep in mind that string length minus 1 will not go negative. And in fact, if I take string length and it's 0 and I subtract 1, this actually turns into about 4 billion, and my loop will execute, more or less indefinitely until I segfault. So that's just a quirky little thing to keep in mind. All right. Other questions on 414? All right. So the other thing I want to talk about is sort of, let's take a step back and think about these ODPs. And what the purpose is of these assignments. And my camera keeps crashing for some reason. I don't know why. The purpose of these ODPs is to get some practice with doing the kinds of things that you're going to be doing as a programmer. Right, the skills that we're trying to develop in this course. So right now we're working with arrays of characters, and we want to develop our skill with constructing, output arrays based on certain properties of an input string. And so I would say probably the main thing you're going to be doing when you're working as a programmer is not so much writing C code or Java or things like that. I mean, you'll be doing that, but that's not really what you're going to be hired for. You're going to be hired to come up with solutions to problems. And those solutions will be things that you'll implement in code, right? But the thing that people will give you a paycheck for is your ability to solve problems, your ability to come up with the algorithms. And then, turning those algorithms into C and compiling those and turning that into something that executes, that's an essential part of the job, right? But that's not the part that people are going to really value you for. It's primarily the ability to come up with the algorithms, to come up with the solutions to problems, to take some large problem like, let's, monitor the temperature in this part of the building, and let's figure out, if there's something going wrong with the heater, and if there is, let's do such and such, right? Coming up with an algorithm to do that, that's the real sort of value add. And these ODPs at this point of the course are really about coming up with algorithms, right? And once you've figured out, what steps you're going to perform to interleave these two strings, yeah, you got to write the for loops. You got to figure out, you know, do I want to do less than or equal to this minus 1, or do I want to do less than this thing? And how do I find the length of a string? And do I want to do a while loop or a for loop? You got to do all that work, right? But the essential part of this is, you know, what's the algorithm? What are the steps? And that's what you're trying to come up with. That's sort of your contribution on a larger scale. And so you know, I started looking at people's solutions for ODP 414, and about 10% of the class turned in this, right? And this is not, you know, a solution that you should be coming up with on your own. And there's a few tells here, right? The first is that, you know, we said don't worry about returning anything, and I mentioned it says you should return an int, but there's nothing in the assignment about what value to return. But, you know, 10% of the class decided to return the length of the new output string. Okay? That same 10% decided that the condition they would use instead of a for loop, instead of checking for a null terminator, was to check to see if both strings had a null terminator. And there's absolutely no reason to do this because both strings have the same length. If A bracket I differs from 0, you're guaranteed B bracket J differs from 0. And so there's no reason to be doing both of these tests. You can pick an A or a B, right? But it's superfluous to check both of them. And you know, so what's the deal here, right? The deal is that, you know, if this happened on a programming assignment, it's a big problem, right? Then we're talking about, you know, zeros on assignments and things like that. Honestly, on an ODP, you know, the ODPs are for your benefit. They're an attempt to, you know, practice what you've been learning, to self-assess to see if you're understanding what you think you're understanding. And if you're not, you know, to be able to see that there's something that I don't quite get and to work on it. And if you don't get it, you know, by office hours the next morning to come by and say, hey, here's what I've got, it's not quite working, you know, what do you think I should do? And to go from there. And you know, turning in code just to get it to assess 10 out of 10, or, you know, changing code randomly to try to get 10 out of 10 doesn't really do much for you. It gets you 10 out of 10, right? But it's a tiny little part of the final grade. The real benefit of the ODPs is you know, figuring out these questions of how to come up with an algorithm, how to think about a problem in terms of a series of steps that I can describe as a program. And you know, I understand there's only limited time in the day, and, you know, people are taking physics and they're taking calculus and you know, all of this stuff. But just keep in mind that, you know, if you can't figure out these ODPs and you don't do something to make sense out of them, right? There's definitely a gap in your skill set there. And there's a good chance it's going to compound. And the 5th programming assignment is going to be all about strings. It's going to be lots of sort of low-level, nitty-gritty string manipulation. And these ODPs are a really good warm-up for that. So that when you get to the 5th programming assignment, which will be next week, you can concentrate on algorithms, right? And the algorithms you're going to try to come up with will be similar in feel to the algorithms we're coming up with this week for the ODPs. So just kind of keep that in mind, and if you can think of these ODPs as learning opportunities that happen to, you know, be worth a few fractions of a point in your final grade, but try to think of them as learning opportunities, and do whatever you can to try to maximize that learning. So with that as a preamble, let's take a look at ODP 416. And this one, as I said, the approach of 414, where we were, you know, having an output position and incrementing that every time we stored, that approach will work pretty well for this one. So ODP 416 is a remove function, and so the goal is to take an input string and produce an output string. Okay, same as what we were doing before. But it's a single input string, single output string. And the behavior is simply remove all the lowercase x's from the input string. So if you call your remove function, your first argument is something like, you know, wxyz, your output string should be wyz. If your input string is xx a xxb, your output string should be ab.
We're basically removing those and moving the positions of the remaining characters.
Exactly. And if your input string is a bunch of x's, your output string should be just, you know, blank. So just a 0 length string. If your input string is, you know, a 0 length string, your output string should be a 0 length string. There's nothing to remove. And these are all valid test cases. And so you know, we can do this on paper pretty easily. We can just go through and we can look for the things that aren't x's, and we can just write those down side by side. Right? So for you and I to do what this assignment is asking for, pretty easy. But to tell a computer how to do this, right, that's the whole challenge. And one way to approach this is to imagine you have a friend. And you're going to hand this friend a piece of paper that has this written on it. And you want to give them instructions so that they hand you back a piece of paper that has this on it. And you want those same instructions to work no matter what you hand them on a piece of paper. So if I hand them this, they'll hand me that back. If we hand them this, they'll hand me that back. And so let's think about, you know, how you would describe to a friend what you want them to do with what you've given them on this piece of paper, so that when they're done, you know, this would turn into this, that would turn into that, and so on. So forgetting about C for a minute, right? What could be a set of steps that you could tell someone?
You could have it look at each spot in the string, and as long as it's less than the string length, basically, like the for loop at the top, and have it look at each character, and if it's equal to X, don't include that in the output string.
Okay.
I'm trying to remember if it was this class or it was last quarter when I took the other class, 250 or whatever it was, and we did a sort. I want to say it was the beginning of this class. We did a sort function that where we saw something, we incremented it, and then basically that's what it was. We did count E.
Yeah.
Modified count E. And instead of incrementing a counter, we would just, if we see the X, we don't increment our string indice counter, and so that the next time we encounter a character that's not an X, we rewrite it in the string indice that is empty.
Okay, I like the sound of that. So let's take this and turn it into something like what you just said. So this idea was look at each character in the input, and if it's equal to an X, don't include it in the output string. Alternatively, we could say if it's not equal to an X, then add to the output string. And this, thank you. this supposes that, you know, we have some output string which is presumably empty to begin with. And then each time we find a character that we want to keep, we'll just sort of, you know, add it to the next position. So, you know, there's an X, that doesn't go in the output. There's an X, it doesn't go in the output. Here's an A, that should go in the output string. So, you know, I've got some sort of output string, and I write my A over here. Here's something else which is not an X. I want to add that to the output string. Well, I don't want to write it right here. I want to write it to the right of what I've already written. And when I come to my C, I want to write that to the right of those two things that I've written. And so this is where we can get into, you know, using a variable to keep track of where we should save our next character in the output string. So add to output string, we could say save in out bracket next location, and then increment next location, so that each time that we add something to our output, it copies it into the next spot in this output array, and then we increment that pointer, that index, so that the next time we do this, it'll go not into the same location, but location to the right of the last one that we wrote. And so if in is our input string and out is our output string, we want to iterate, right? Look at each character in the input. And someone mentioned a for loop. And someone mentioned a string length. So let's play with that for a minute. So I'm going to make a bogus input string and an output string. And let's just look at each character in the input. And so one way we can do this is with a for loop. So we're going to use I as an index to read our input string characters. And we're going to begin with I equals 0. Why? Because the first character of a string is always index 0. And we have to think about this string math. So if I have a string like A, X, B, string length will return 3. String length always tells me how many characters I have, not including the null terminator. And my goal in this case would be to go through the loop a total of 3 times to process elements 0, 1, and 2. So I want to iterate starting from 0 up to and including the biggest integer less than this string length. So that leads me to think about a condition like I is less than string length of in. And then the I++ says increment your index at the bottom of the loop. And let's just test this out. So I'm going to print out I equals, and I'll print the value of I. And then I'm going to print out in bracket I equals, and I'll print the value of in bracket I. So I'll look at each character in my string inside this for loop. And I'm going to print my character inside angle brackets. So that if it's got, you know, a space in it, for example, I'll see a space between the angle brackets. And I'm not going to do anything else in here. I'm just going to use this as kind of a piece of test code. So I'll compile that and I'll run it. Remember, our input string here is AXX, BX, CXX. And so as I go through my loop, there's my AXX, BX, CXX. And it hit every single character in my input exactly once, and then it stopped after that last character. So this feels like a good loop structure. Now if I happen to do I less than or equal to string length, it does exactly the same thing, except it goes through one more time and it picks up the null terminator. That last time through the loop, I is equal to 0, in bracket I is the null terminator. That's this nothing that we don't see in between the two brackets. So if I want to do processing on the null terminator, I can go up to and including string length. Otherwise, I can do less than. And just as a reminder of this gotcha, if I do less than or equal to string length minus 1, that works great except when my string is empty. And it turns out if my string is empty, this is not going to work. So if I set my in,
if we want to actually print out the null terminator and see the null terminator character.
You could print it out as a %d and you'd see a 0. But we can't, if we print it as a %c, it's a non-printable character. If we have a string that, is just a null terminator, printf will stop before it shows you the null terminator. So, but it's really just a short integer whose value is 0. So this less than or equal to string length minus 1 works great, except when your input string is null. And if your input string is actually null, this goes into an infinite loop until it seg faults. And so that's just some kind of goofiness of string length. So your cleanest way is either go less than string length or to do a while loop and do while in bracket I is not the null terminator. That'll work also. So if I just want to print the characters that are not X, I can do something like if in bracket I is not equal to an X, and then put my print statement inside that. Now when I run this, I just get my ABC. And that's almost ODP 416, except that, to turn this into an output string, well, I got my A at index 0, I got my B at index 3, I got my C at index 5. I can't copy A into output 0, B into output 3, C into output 5, because they're going to have extra stuff in between. So this is where we want to do something like have, a next location. So do your for loop. So if your input character I is not X, then set your out bracket next location equal to in bracket I, and then increment your next location. So if I initialize next location to 0, then I would copy A into output 0. I'd increment next location to 1. When I get to B a few steps later, that would get copied to output character 1. Increment next location to 2, and when I eventually get to my C, that'll go into output location 2. Increment my next location to 3. So that would store my ABC in successive locations, And then when I'm all done with this, write the null terminator. And if I'm doing something like this, right, I'm thinking of next loc is where the next location is to save something in my output string. So you got to turn that into C. You got to add brackets and initialize things and stuff like that. But that's an example of the algorithm. And so code that up, write some test cases, make sure you do some degenerate test cases, like, you know, an empty string, a string containing a single x, a string containing just a bunch of x's, a string containing a single character with some x's, a string containing an x in the beginning and an x at the end. Try a bunch of test cases. And then once you're passing all of your test cases, go ahead and run the assess command and try it on the assess test cases. All right, so questions about that?
The null terminator, I'm having a little bit of a brain fart on. Is that gonna, if we are incrementing our next location, like an if statement after the for loop, that's already gonna end up where we want the null terminator, right?
Exactly, yeah. So if I initialize next loc to 0, I can think of that as, you know, index where we store next character, or the null terminator. So each time we find a character store, we just store it at next loc. When we're done, next loc is still where we want to store the next thing in our output string. That's where we store the null terminator. And then once you got this working, ODP 417 tomorrow is a very small modification to this. But once you got 416 looking, take a look at the README for 417 and think about how you have to modify 416. But you can't assess 417 till tomorrow, so don't try to run it through the assessment. All right, let's talk about processing your calendar file. And I want to talk about a command called grep. And grep is, you know, a whole lecture or maybe a whole class in itself. But there's a really simple way of using grep that will help us. So here's a file called cal data. This is a totally bogus example file of you know, something containing, in my case, a username, a date, and an appointment description. And so I've just got, you know, pipes separating my fields because my description has spaces in it. So I use something I don't expect to pop up in my description, like a pipe or a tilde or something. And it's just name, date, and a description. Suppose that you have this file and you want to write something in your bash script that says, show me all of the appointments that are happening on the 8th of November. So let me throw a few more things in here. Right? So the grep command basically says, you can say grep space, type in a pattern you're looking for, space, and then a file name. So if I grep for 2021-1108 inside my cal data, this will pull out all the lines for November 8th. How do you make a bash script return prematurely? Exit will get you out. If it's not working, you're probably doing something outside of the script that you're exiting. But exit will kick you out of a script right away. So if that's not happening, come by and show me. in office hours.
So I got a quick question with the grep. Is there a modifier so like our date is set up with slashes to ignore those characters?
There is. So we can wildcard things in grep. You can use a period as a wild card, but that starts to get into a bigger topic, which has to do with regular expressions. But if your date has slashes, I would just put slashes in the thing that you're grepping for, like grep 2021-1108, and search for it like that.
Oh, so you can use this command as like for the grep, and then the some person have a variable to be declared by the user.
Yeah, so I could say read date, and you know, I would do this from a dialog, but you know, you pick a calendar date, and now I've got a variable called date that has this thing in here. I can use this inside a grep search and pull out things that match that pattern.
Okay. So for this assignment in particular, we don't need to get too fancy if we just ask the user what date, right? And they have to put it in.
Yeah,
correctly.
yeah.
We have to assume that they're going to do it right.
Well, if they're picking a date using the calendar dialog, which is what they should be using, you get that back in a particular format, but you can restructure that using some of the stuff we did with sed. With awk, where we specified a field separator, and then we use print statements. And so you can turn it into whatever format you want, and you can put all of that into a variable like this, and then search for that pattern. The other side of this is when you're working on your delete function, right? You may want to get rid of all the appointments, you know, for the 8th. So for grep, we can do a grep-v, and that says show me all the records that don't contain a particular pattern. So if I say grep-v $date, I get all the records, and put in the name of the file. I get all the records that don't contain 2021-1108. And if I do this and I, you know, put this into a new file temp, now this new file is my original cal data with those records deleted. And now if I were to move temp or copy temp to cal data, I've basically deleted records. And so grep-v is a nice, easy way to basically remove records. Are we allowed to use for loops in PA4? My only hesitation on saying yes is that I don't want you to use them on the final exam. But if you want to use them in PA4, that's okay. You shouldn't have to. You should be able to do a while loop also. But yeah, you can use them in PA4, but on the final exam it'll still say no for loops. So just make sure you don't extend that into the exam. All right. The other thing is, you know, you read a line from the user, and so you know, here's Sally, and this is on Christmas, and they're going to, you know, open presents, right? So you've done your dialogue, and you've got a new appointment from the user, and you want to add this to the calendar data file, right? We can say echo and put in the name of that variable that contains this information, so new data. And if we just echo that, it prints it to standard out. Well, if we echo, but we greater than cal data, greater says append. And so now when I look at cal data, it's got this new appointment at the bottom. And so that's a pretty easy way. After you've done the dialogue and you've got the input from the user and you've put it in the format that you're using, you can append it to the bottom of your calendar file by just echoing it with a greater. Let's see, is it possible to have awk ignore spaces and only take into account the field separator? Well, if you specify the field separator as, like, you know, a slash or a comma, then spaces are just like any other character. They're neither ignored nor treated specially. If you want to get rid of spaces, we can start talking about something called sed, and we'll probably talk about sed tomorrow. But sed is a stream editor. It's a way to do VI-like commands on a file. And for example, I could say sed substitute a space with nothing inside my cal data, and it'll get rid of all my spaces, right? So I've just like munged up all my spaces in my description. And so I don't know if that's going to help or not, but we can talk about that tomorrow. We are so out of time right now. Send me a ping on the way out, and have a great afternoon, and I will see you all tomorrow.